Jocelyn Bell story. These microphones that are designed for a man's coat pocket and a man's lapel. And so girls started wearing jackets after Jocelyn Bell said that.
Okay, so let me pin this on you here. See if that works. Do you have a pocket? Yes.
Yes, that's the box. I think
Okay.
put that in that pocket and then this
All right,
goes
go
in.
ahead.
There we go.
I didn't know where you wanted it. All right, so in
Okay.
principle, the way this works.
Now we're tied together at the
Oh.
moment.
Oh, all right. So if you want to use this
What is the simplest way to make it go forward?
that way, just
That
push
way.
that button.
Yes, you're right.
Okay.
Okay.
So may I introduce you?
Yes.
All right. Our next speaker needs no introduction.
Which is why we chose him to do
Right.
it.
So Virginia Trimble, I'm really honored to introduce Virginia. She's been the de facto historian of HEAD. She's been around since.
Careful.
She's been around for almost as long as me. How's that? In fact, those of you who are familiar when the AS had its centennial history, she wrote the HEAD section, so she knows more about us probably than anybody else in the room. How's that? Okay, so with that, Virginia.
Okay. 50 plus or minus 50 years, because many things go back a long ways. Those are two failures at timelines. And in not large enough print is the name of Alison Lara, who collected all the photographs for me. What's going to happen for the next few minutes? Oh, Fearless Leader. Where did you go, Fearless Leader? Fearless Leader. There we go. Okay. Fearless Leader, tell me 3 minutes before you want me to stop. Okay. Yeah, I see the problem. You know, you don't have to touch the button. It does electrical something or other. It's all the fault of J.C. Maxwell and probably the displacement current. Kelvin went to his grave not believing the displacement current, and he has my sympathy. Okay. Timelines, Alison Lara, who collected the pictures. What you're going to have is an alternation between text with, I hope, mostly facts, and a large number of pictures of people, 3 at a time, except the first couple. And there'll be a prize at the end for the person who can identify most of the people in the groups of 3. There are actually 21 of those things. You'll see each one of them for about 10 seconds. It's a total of 63 people who are all part of our history in different ways. And I'm not good at faces, but I have a list of their names. And so the first prize winner will actually get a printout of the pictures. The second prize winner will get only a list of the names. So we're going to step first into the history of pulsars. We are. That was the Rome Pulsar meeting in December 1969. I'm standing with Jeff Scargill. Yeah, you know, once upon a time I was young and beautiful. It's hard to believe, but it was true. There I am with Jeff Scargill, and the other 2 gentlemen are Peter Scheuer of Cambridge and Roderick Willstrop. And Scheuer was a theorist of radio source counts, and that was important for cosmology in its day. Jeff and I did this 3rd and 4th PhD dissertations ever on the Crab Nebula. Now, those are the founding members of HEAD, and their status in 1999, many still AAS members, many still division members, a modest few deceased, and some alive but in other places. Now we get 2 seconds of our first set of people. Summary. I said you were going to get 2 seconds each, or I won't be able to tell you all the important things I have to tell you. A summary. This is very sensitive. Okay. Hands in my pockets. Some of our topics go back many, many years. World War II enabled technology, radar and rockets that led to a flood of discoveries. The Cold War considerations, Sputnik led to rapid science population growth in the US and other places. At least 3 organizations, the AAS, the American Physical Society, and the International Astronomical Union, the pileup of people and interesting problems led to a desire for new organizations all the same year. And here we are, some years later. I'll expand on some of these, stick in some well-known case studies, and tell the chairs, you can read that for yourself. Sit down, but preferably not on the chair. Okay. Forward. Sociological issues, mostly from a US point of view. Sputnik scared the hell out of many of us. I remember this because it gave rise to PSSC physics, which made a big difference in how physics was taught for about 3 years, until the people who'd invented it moved on to other things. Most organizations do well as long as their founders, the people who first cared, run them. This shed some light on some other organizations, which I shall not mention for the moment. But it led to many, many young scientists taking interest in the field, lots of new discoveries like the timeline. And the result was a critical mass that accreted, that led to HEAD, the Division of Cosmic Physics, and Commission 48 of the IAU, 60 to 80 people in each case. And there were all those launches very quickly. The first decade, there were more than 800 satellite launches, including some failures and quite a few classified projects. There was internal Russian jockeying for positions among groups of leaders of high-energy astrophysics. Vita Lazarevich Ginzburg, Yosef Samuelevich Shklovsky, Yakov Borisevich Zeldovich. I knew them all, of course. Ginzburg outlived the other two, and so it's his version of history that is to be found in annual reviews and another of his autobiographies. As you can probably guess from their names, they were all Jewish. And as the pictures go by, there will be amongst the founders of the field all over the world an excess of Jews, including me. The first US science discovery was the Van Allen belt from Explorer 1. It was in the Sputnik data, but the Sputnik people wouldn't let the Australians have their code, and the Australians wouldn't let them have the data. The first X-ray discovery from Ariel in 1962, the first gamma ray discovery from Ranger 3, the work of one of Jim Arnold's detectors, where the probe missed the moon and so looked out in the sky. And it's from this period where they said, 1 photon is a discovery, 2 is a spectrum, and 3 is the Rossi Prize. That was Herb Gursky. But we heard just yesterday about these things with 10 to the 8 photons. Ricardo, you're allowed to recognize. Blast. Okay, definitions. What is high-energy astrophysics? It first appears in print in 1966, just before we were founded. And Olivier Breton, who ran a summer school, said it was events that used lots of energy or put out lots of energy at a high rate. In other words, high energy per event or per source, not per photon. Ginzburg said it was high energy per photon or particle. Had started out, see in a minute the list of founders, more like the Graton, and has evolved with occasional discussion and dispute to the Ginzburg view. The Texas Symposium covers almost the same territory, but wider and narrower and all over the place. Now they choose the topics before the abstracts are submitted, so that somewhat narrows the territory. And GRG, the International Society on General Relativity and Gravitation, actually goes back to 1955. That was GR0. I was not there. Some people who were there are still alive and answer their own email. I shan't tell you who you might bother them. But GR0 had 85 scientific participants, and there were 3 women. Yvonne Choquet, Mademoiselle Malfredise, and Brunia Kaufmann, whom probably nobody has heard of, but her third husband was Willis Lamb of the Lamb Shift. That's your useless fact for today. Well, more useless than all the others. But many groups felt the need to do these things in about the same time frame. This is, again, the founders. The red lines, I'm afraid, are people who are no longer with us. There are a couple where I couldn't actually tell. People lost to follow-up who ceased to be scientists. It's awfully hard to lose an astronomer or a physicist, but you can lose somebody that totally leaves the field. But less than, well, about half gone, realistically. More people. Where are they now? The founders who are now still members of the division, still AAS members, at least active in the IAU, alive because I've heard from them recently, but not very active in science, and a few, again, lost to follow-up. If anybody knows what's become of Morton Kaplan, Kinsey, or Whit Whiting, I would be interested to know. These are the early leaders of the division, and the curious thing was how quickly non-founders became involved. The very first actual appointed or elected committee had at least one non-founder, and soon all the foreigners were taking over the leadership. It happened very quickly. And the pattern of vice chair becomes chair, and many of the secretary treasurers then became vice chair and then chair. More people. That's Maury Shapiro, I have to tell you that. And these are the founders of the IAU Commission on High Energy Astrophysics, and the asterisks are people who also belonged ahead early in its history. And again, many, of course, are no longer with us. But there's a line drawn there because in order to join the IAU, you have to have had your PhD for 3 years. And that cuts out, well, now they have junior members. It used to cut out young people. And it cuts out citizen scientists, independent scholars who never do PhDs. And that's what happened to the founding members. Again, some of them are with us, many are not. And the lost fraction is larger because of this lower limit to the age of the founders. The membership of the Division of Cosmic Physics, the physicists didn't keep very good records. Nobody knows who the founding members were, but these are at least the early officers, and the vast majority were cosmic ray people, although again, a lot of overlap with members of the High Energy Astrophysics Division of AAS. Eventually there were some, I traced that down to the first female chair was Angela Minto, and later chairs included Miriam Foreman, Alice Harding, who's here, and me. And I think I'm here. Repeated discoveries. Isotropic is either cosmological or nearby, and that was the radio sources in the 50s, the X-ray sources, and the gamma ray bursts, which are already out of our period. They're after the founding of the division. But the isotropy of the GRBs and the fact that one saw the turnover in log N, log S meant that they were truly cosmological. And they were the first sources where cosmological properties dominated evolution. A real missed opportunity. In 1949, someone said, stars with strong magnetic fields and rapid rotation will accelerate electrons to have very high potential and be radio sources. Guess who said that? It's a prediction of an effect of pulsars. And it's not Tommy Gold or Franco Pacini, who also predicted pulsars. That's Martin Ryle. Very strange. Neutron stars should have strong magnetic fields and rotate rapidly. Gold, Pacini, Vulture. Obviously, neutron stars should be radio sources. And yet it came as a surprise when they were discovered in late 1967. Oh, incidentally, Jocelyn Bell was with us at Irvine last week as our fifth Rhino structure. That's Phil Morrison on the left. Universe of Discourse. I'm going to do a bunch of case studies until the chairman tells me to shut up, because there are things that have been part of our universe of discourse for a long time, going back before the division, and things that only came along after the division I won't actually mention. But compact sources, AGN jets, radiation mechanisms, a whole bunch. You've heard about several of the cases today where you can't tell the difference between synchrotron, Bremsstrahlung, and inverse Compton. Cosmic rays have been there for a long time. Sociology, I've mentioned already. High energy neutrinos, gravitational radiation or waves. How many of you know the name of my husband? If you want to know, ask one of the people with his hand up. I'm not going to say it. Well, let me explain. I learned something from Christine's talk. It's a mistake to try to talk in public about people you love. It goes badly. The tears start dripping down. Okay. High energy neutrinos, gravitational radiation, and specific examples, more people. Our folks on the V2 panels, the early government involvement, which included a rocket board, a panel, a space science board, Fred Whipple from the get-go, Van Allen, Pickering, Kellogg, Herb Friedman, Sidney Chapman, Chubb, again an X-ray person, Jastrow, O'Keefe, and Clements from the USNO, and again Goldberg and McDonald and lots of other people early involved in this space program part. More people. Schramm in the middle. Subdisciplinary divisions. The AAS is weird. We're the only organization that has divisions of our minor topics. APS, the major divisions are condensed matter, particle physics, plasma. We have the fringes. I don't know why, we just do. American Chem Society is enormous. They have about 50 divisions. That's the American Psychological Society. I ran across that someplace. And others that have none, like the RAS and the European Society and so forth. In all cases except us, they're the major subfields. More people. Topics at the Texas Symposium, quite a lot of overlap with here. Gravity, strong tests, messengers, cosmic rays, relativity at work. And the GR22, which is happening in July in Valencia again, a lot of topical overlap, but look for yourself on their website. Supernovae. The stellar nova of Tycho and Kepler, 2 classes from Lundmark, Curtis, the Crab and a guest star, Bada and Zwicky, Balmer lines, 2 types of spectra. Collapse triggered by neutrino production, George Gamow and others. ATT, WAW, and then there was a war. Many of our bits of history have that line in them, most for World War II, but a few for World War I. And then Bondi, Golden, Hoyle, steady state, and B squared FH on nucleosynthesis. Fowler and Hoyle on nuclear explosions in Colgate to make supernovae. Zwicky, the decay idea of the long-term supernova light curve goes back to Zwicky, and there was Borst and Bada and Robert Christie misspelled, I'm sorry, and Pankey. And 2 of those people, Borst and Pankey, you have to look hard to find out even who they were, and they have almost no trace. One of them was still alive the first time I looked into this. I phoned and asked how he thought of this, and he didn't remember. It wasn't terribly helpful. And on down to the present with radio and optical and supernova 1987 and all that good stuff. People, Uncle Willie on the left. Synchrotron radiation. The idea is right there in Maxwell's equations. It's in a textbook from 1912. And then there was a war. And laboratory detections. The astrophysics comes late. Alfvén and Herlufsen. I have to tell you about Kiepenheuer. Kiepenheuer wanted to put an X-ray or an ultraviolet detector on a V2 rocket and launched it in 1943. By the time they had the detector developed, they needed their V2 launches for something else. So it was left for Herb Friedman to put the X-ray detector on a V2 rocket and see X-rays from the sun in 1949. Ginsberg, Pekelner, Shklovsky all claim credit for thinking of this first. Observations and Bremstal not being enough to account for the Jansky and the Reber sources. Radio stars. Curiously, the point radio sources that the Cambridge people found showed no polarization. I don't know why. But the Crab polarization seen in the optical Dombrovsky-Assad case, he spent the rest of his career looking for polarization of other nebulae. And of course, there weren't any more people. Galaxies, clusters, and clusters of clusters. If you look at NGC, the catalog, you can see the Virgo and Coma clusters on the sky. And then you have to have external galaxies. Shapley thought clustering was common. Hubble couldn't see clustering. Shapley said to Hubble, your telescope is too big. This isn't something you often say. 1961, superclusters existed. Zwicky said not. And Abel found a mass for the supercluster of about 10 to the 15 solar masses. Zwicky said no superclustering, and therefore the mass of the graviton is 10 to the minus 63 grams, or 10 to the minus 27 eV. That's much smaller than the LIGO limit, actually. Top-down formation, bottom-up formation, Zeldovich, Egan, Lindenbell, and Sandage, Peoples. Most of them no longer with us. Oh, that's a picture. Oh, yes, that's the Mount Wilson 100-inch with me reflected in the mirror and my thesis advisor, 1966. I was going to go look for, I don't know what I was looking for. Neutron stars, the idea, Chadwick, Landau. Oh, read that Landau paper in Nature and see if you can figure out what the deuce it's about. The 1933 December APS, where Bada and Zwicky put forward neutron stars, supernovae, cosmic rays, Oppenheimer and Volkoff, and then there was a war. And a 1949 missed opportunity. The single neutron stars, Bell and Hewish, of course, binaries, SCO-X1 was the first. It took a long time to show that SCO-X1 was a binary. Its light curve is such a mess, but Hercules X1 was easier to see. Equations of state, the first one in Lemaitre's thesis, and he did a thesis in GR with a bunch of things in it, some cosmology, but also what we now call the Tolman-Oppenheimer-Volkoff equation of state, and then Tolman-Oppenheimer-Volkoff, general relativity equals quantum mechanics, beta and all, more people. Bending of light and gravitational lensing. This is too long to go through, but Newton had the idea that light should be bent by massive bodies. And you can do a calculation assuming that photons are particles and they respond like any other particle, and you'll get it right to within a factor of 2. There was good old Zollner, who was invoked by the Nazis later as having done it so well you didn't need Einstein. Early GR. Tolson, yes. He wrote about fake double stars, but he shows an image that's like an Einstein ring. It's a very interesting paper. Perhaps the most interesting thing about that 1924 paper, it's only half a page, and the article immediately under it is by Einstein. So Einstein must have seen Tolson's Einstein ring, although he hadn't thought of it yet for himself. And here's R.W. Mandel writing to Einstein and complaining to Zworykin that Einstein paid no attention. Zworykin tells Zwicky about it. Zwicky figures out that galaxy-galaxy blending is much more likely than star-star, and he was quite right. We now call these Zwicky telescopes, and got to talk about it sometime yesterday. Bundling of rays, first strong lens. Oh, yes. An exception to my rule. Jim Gunn did the first PhD dissertation on what we now call weak gravitational lensing. It was Alan Sandage's suggestion that you could put a limit on cosmological models by how the shapes of elliptical galaxies look different in the past. And it turns out that bending of light dominates the evolutionary effect. And this was just after Jim had defended his thesis, and I was congratulating him. The gentleman with the cigarette in his hand looking the wrong direction is Guido Munch, who was both of our advisors, and the person walking away is Robert Christie. AGNs, FATH, 1908. The ray from M87, H.D. Curtis. Heber Daust Curtis. I learned how to pronounce his middle name by phoning his last living student and asking. I was told to rhyme with soused. No? I think it's funny. And then there was the war, and Cygnus A, and many more goodies, and optical identifications. Sandage mystified by the spectrum of 3C48, and then, of course, Schmidt identifying the spectral lines in a position in the sky provided by Cyril Hazard. Salpeter and Zeldovich saying a central collapsed object, and that became fashionable. Now, very fashionable. More people. White dwarfs and novae. The very first real nova was C.K. Vulpeculi. The previous ones were supernovae. Oh yes, another out of, what is this? This is measurement of the Einstein redshift, the gravitational redshift of white dwarfs. When I started this project, there were 2 known. When we finished, there were 50. It got to be my project because Jesse Greenstein had tried to measure the plates himself and couldn't make any sense of them. He handed them to an expert. Remember, computers used to be women who did scut work. He handed it to his computer. She couldn't do it. It was given to me in my second-year research project on the grounds it didn't matter that it couldn't be done because I wasn't going to be an astronomer. Jesse was also the person who said, at the launch of Space Telescope, Hubble finally got the telescope he deserved with the mirror flaw. Yeah, right. The speed of gravity, Poincaré said it was equal to c. Einstein said so too. Yes, no, decades of disputing whether or not gravitational waves would carry energy. There's a whole book about by Daniel Kennefick. It's rather good. GR2 Royalmont was debated. Infeld was not there. Of Einstein's co-workers, they weren't his students. They were his computers, frankly, but they were guys. And Einstein's deliberate choice made them all Jewish. But Einstein had infected Infeld with the idea that no energy would be carried. And that was debated at the Royal Mount meeting. And Bondi said you shouldn't vote because Infeld wasn't there. Anyway, the first interferometer detector was built in 1969 by Robert Forward at Hughes. More people. Black holes, John Mitchell and Laplace, you may have heard about. Carl Schwarzschild, you may have heard about. And he says I have 3 minutes. That's okay. I'll get through all the pictures. We'll miss some of the hard facts, but they're all there. Oh, was that it? No. Blast and damnation. Okay. Back up. Quickly forward. Oh, that's my black hole. It's supposed to look like that. I remember it took 2 tries to get my black hole photograph, and there it is. Yes, of course. Black hole photographs are very, very expensive. And more people. And the Crab Nebula. This is my thesis. But 1054 and M1, Messier's first object, the name from Lord Rosse, William Parsons. His drawing looks like a pineapple. Phil Morrison noticed that years ago. The radio and optical identifications of the supernova, the pulsar and the P dot, and the first symposium on a single object, except for the Sun, IAU Symposium 46. And there's the crab. This is actually a fun picture. The idea came from Fritz Vicky. If you want to see changes, take the positive of one picture and the negative of one from a different time and superimpose them. And so everything that's moved is white on one side and black on the other. The stars are saturated. You can see the crab expanding. And other people printed this without my permission. It's from my thesis. I think, yes, the Crab Nebula was our last picture. Okay. And you can't go backwards with this device, but that's okay. So having used up my 3.5 minutes out of the 3, thank you very much.